Hey everyone. So, I built something, and I need you to understand why it matters. I've spent a significant amount of time building a secure messaging application called Vault, or that is the current name for it. We don't have an official name yet. And before you scroll past thinking, oh cool, another app. Well, please listen to what I have to say because what I built isn't just another app. It's something that fundamentally changes what privacy on the internet actually means. Let me explain it in plain English. First, why does this even matter? Every single day, billions of people send messages across the internet. So they assume that they're private, right? Like WhatsApp says end-to-end encrypted, Telegram has a green lock icon, iMessage shows a blue bubble. People see those things and think their conversations are safe. Well, they're not. Not really. Here's what most people don't know. The majority of those apps require you to have a phone number to sign up. That phone number is tied to your name, your carrier, your billing address, and your government ID in most countries. The moment you register, there is a permanent searchable link between your encrypted account and your real identity. Law enforcement can subpoena it, hackers can social engineer it, your carrier can be targeted. The encryption on the messages might be solid, but you are the vulnerability. So beyond that, most of these platforms store your messages on their servers, even encrypted ones, and their servers hold the keys to decrypt them, which means if a government issues a court order or if a hacker gets in, if a rogue employee goes looking, your conversations can be exposed, going back years. So Vault was built to make all of that impossible. Not difficult, impossible. So here's what Vault actually does, in terms anyone can understand. When you open Vault for the first time, your device generates a unique cryptographic identity, not a username, not a password that a server signs you, a mathematical identity, 2 pairs of cryptographic keys generated entirely on your device in your browser that never travel anywhere, because this application is built on the browser. So there's no identity of you being able to be tracked if you're like on an Apple device or an Android getting it from the App Store that would link you. So your Vault address is a 16-character string that looks something like, for example, A3F19C2B 7E40D81A. That's it. No name, no phone number, no email, no date of birth, no location, absolutely nothing. So you share that address with the person you want to talk to. They enter it, and that's the entire account creation process. There is no user database on the server with your name in it. There can't be. We never asked for it. Now here's the part that genuinely amazes me when I think about it. When you send a message in Vault, here's what happens. Your device and your contact's device perform a mathematical handshake called X3DH Extended Triple Diffie-Hellman. This is the same protocol used by Signal, which is widely considered the gold standard of secure communication and is recommended by cybersecurity experts, the US Senate, and even Edward Snowden himself. This handshake produces a shared secret, a unique encryption key that exists only on your 2 devices. It was never sent across the internet, not even once. An outside observer watching every single packet of data that traveled between your device, the server, and your contact's device could capture everything and still be unable to reconstruct that key. The mathematics of the handshake make it computationally infeasible. So this isn't a claim about how strong the lock is, it's a claim about the fundamental structure of the problem, like saying you can't unscramble an egg. But we went further, much further. After that first handshake, Vault uses something called the double ratchet algorithm. Here's what that means in plain terms. Every single message you send is encrypted with a brand new, unique key, not the same key reused, a completely new one derived mathematically from the previous state. So the moment that message is encrypted and sent, the key used to encrypt it is deleted. It ceases to exist anywhere on the planet. So this means something extraordinary. Even if someone somehow obtained your device today, they cannot read a single message from yesterday's conversation. Those keys are gone. Permanently, mathematically gone. You cannot recover them. The government can't recover them. We cannot recover them. They no longer exist anywhere. And it works the other way too. If someone somehow compromised your keys in this moment, the ratchet advances with each new message until it reaches fresh key material that the compromised snapshot never had. Your conversation heals itself automatically. The attacker's window closes on its own. So here's where I want you to really think about something. Let's say you're at a coffee shop like Starbucks or something. You're doing some work on your computer, the Wi-Fi's open, and you're connected to a network owned by a stranger, monitored by who knows who, potentially running software that captures every packet leaving your laptop. With most apps and applications, that's a meaningful threat vector. Credentials, session tokens, metadata, it all travels through that network. But with Vault, it doesn't matter at all. By the time your message hits that network, it has already been encrypted with a key that was derived from your private key, which never left your device, and your contact's public key. The network sees gibberish, not hard to read, gibberish. Mathematically irreversible gibberish encrypted with AES 256 GCM, which is the same encryption standard used by the United States military and banking institutions globally. The only way to decrypt it is with a key that exists only on your contact's device. You could send a Vault message from inside a room where every single packet is being recorded by a nation-state intelligence agency, and the content of that message would remain completely private. Not probably private, not hard to crack, unreadable, permanently. So you might be asking, well, what about the server? Can't someone hack it? Well, yes, and it wouldn't matter. Here's what our server stores. It stores encrypted blobs it cannot decrypt, the public keys of registered users, which are public by design and reveal nothing sensitive, and messages timestamps. That is it. Our server does not hold any key that decrypts any message. Our server does not know who sent any message. The sender's identity is encrypted inside the payload of the message being sent before it leaves the sender's device. So the server only ever sees who a message is being delivered to, never who sent it. If our server was hacked tomorrow, completely, totally root access, everything, the attacker would get a list of public keys and encrypted blobs that have no way to decrypt. They would have nothing. This isn't a promise about how careful we are with our security practices. It's a statement about the architecture. We architected it so that compromising the server gives an attacker nothing useful. And there's more. Safety numbers. So, even the strongest encryption has one theoretical weakness. What if someone intercepted the initial key exchange and substituted their own key, and potentially positioning themselves as a silent middleman, reading every message as it passes through? Well, Vault has a solution. Safety numbers. So each conversation generates a unique 60-digit number, computed individually by both parties from their actual cryptographic keys. If you and your contact compare those numbers over a phone call, in person, or wherever, and they match, you have mathematical proof that no one has substituted a fake key. You're talking directly to each other with no one in the middle. And your keys are protected even if your device is stolen. Your private keys never sit unprotected on your device. They are also wrapped in AES 256 GCM encryption, secured by your passphrase, which is run through, and if you don't understand, that's fine, but for those of you that do, 310,000 rounds of PBK DF2 SHA 256 key derivation before it touches your keys. So what that means practically is if someone stole your device and tried to brute force your passphrase by guessing millions of combinations, each guess, it takes approximately 1 second. So guessing 1 billion passphrases would take about 31 years. Your keys are safe, even on a completely seized device. So let me compare this directly to what you're probably using today. Let's start with WhatsApp. Its end-to-end encryption is real, but your phone number is your identity. Meta stores metadata. Backups to iCloud or Google Drive have historically broken encryption. Meta has compiled with thousands of law enforcement requests. Well, what about Telegram? So here's the funny thing that most people don't know. Standard chats are not end-to-end encrypted. They sit on Telegram servers in readable form. But the only way to get through that and bypass it is if you enable secret chats, and they are end-to-end encrypted. And they use a custom protocol that, well, a lot of cryptographers have criticized for years. The vast majority of Telegram users have never used a secret chat. Well, what about if you have an iPhone? Let's just say you're using iMessage, right? So, honestly, it's great encryption between Apple devices, but the problem is iCloud backs up store messages histories accessible to them. And Apple has complied with government requests tied to your Apple ID, your payment information, and your real identity. What about Signal? ones that a lot of government entities use. They consider it the gold standard, and yes, it is genuinely excellent. It uses X3DH and the double ratchet. Vault matches Signal on every cryptographic dimension, but there's one key difference. Signal requires a phone number. That phone number ties your Signal account to a real-world identity that can be subpoenaed, traced, and exploited. And the crazy thing about that is if someone did hack into your device and because they had a court order for a subpoena, they can look at your Signal stuff if you didn't delete it. But Vault requires nothing. No phone number, no email, no name, no identity anchor of any kind. So essentially what I built is this: a messaging system where your identity is a mathematical object, not a personal detail, where encryption keys are generated on your device and never leave it, where every message gets its own unique key that is deleted the moment it's used, where the server holds nothing that could compromise your privacy, even if it were handed over in full to any authority anywhere in the world, where the sender of every message is invisible to the network, where even a total adversary controlling the entire network between you and your contact cannot read what you're saying. So this is what real privacy looks like. Not a terms of service, not a privacy policy, not a green lock icon. Mathematical guarantees built into the foundation of the system. So I built this from scratch. Every single cryptographic operation, the X3DH handshake, the double ratchet state machine, the sealed sender envelope, and if you know what this is, you don't have to, that's fine, the ED25519 signature chain, the passphrase protected key storage, implemented directly from the public and published specifications of the protocols used by the world's most trusted secure communication systems. And the great thing about this is I'm releasing it open source, because security software only earns trust through transparency. Anyone can read the code, anyone can verify the claims. And that's how it should be. So privacy isn't a feature, it's a right. And now there's a tool that actually protects it. Vault. Not the official name, but it is zero identity, zero knowledge, zero compromise. The server will be up and running by the end of the year, 100% free.